Hi guys, and welcome to this video on analysing reducing balance loans with recurrence relations. Shorter titles would be good. If you've been following along, this will be the second video in this particular series of videos that is actually going to power into financial maths using the financial server on your calculator. So the good news is, we're almost at the end of doing the hard work pencil and paper way. Breathe a sigh of relief, but we're not quite there yet. We've just got this video to go. Thank you so much for joining me. If you have not been here before, can you subscribe by clicking the doohickey shown in the corner? As I say at the beginning of every video, knowing you're watching is really, really important to me. It keeps me going, strangely enough. It just helps me have that little bit of excitement. Videos are also on MaffsGuru.com, where they are linked by textbook and chapter with downloadable notes. Head on over there if you can. Sign up for free, and I don't see how you could need anything else. All right, so in the previous video, we looked at the idea that we could use recurrence relations to model all sorts of different stuff. And we came up with a formula where we had V0, he does it with a highlighter again, where we had V0 was some sort of starting amount. So I'll just do a starting amount, and then we had that V of n plus 1 was equal to some multiplier times V of n plus or minus some sort of payment. Yeah. Now, again, we talked about investments, we talked about loans. If you haven't watched the previous video, head over there and have a look. But we found that this here was really important. Further maths uses the same stuff over and over again. For some reason, we just call it different things. And so if we just look at basically, as I've just said here, the idea of this formula, that's exactly what I've written here. But what do you notice? Now I've got a minus. So this is going to reduce. Assuming that the value of D, this value of D, is bigger than whatever this R times V of n becomes, then I'm going to reduce. It's like having a loan that's having interest charged and I'm paying stuff off, like my mortgage, for example, yes? Here we've called it the principal, right? Our starting amount, it's got so many different names, but it's that first number, that first thing we are starting with. And we've got to remember that this value of R here is given by 1 plus R on 100, where the value of R is normally given as some sort of interest rate, yes, per compounding period. So it's always good to start with an example, and we have one here from the Cambridge Further Maths Units 3 and 4 textbooks. Thank you, Cambridge, for allowing me to use your examples. Alyssa borrows $1,000 at a rate of 15% per annum compounding monthly. There is pretty much all of our important information. She will repay the loan by making 4 monthly payments of $257.85. Okay, so construct a recurrence relation to model that. We can do that, and it's got to be in this form here. So the value we need to work out is the value of R. If we remember, R is equal to 1 plus little r on 100. So what is that value of little r? It is not 15%. Our 15%, if you remember, is per annum. And if you haven't watched the video on effective and nominal interest rates, go back because it explains how to do this step. It is compounding monthly. So we have to turn this per annum figure into a per month. And the way we do that is we do 15 divided by 12, which is equal to 15 divided by 12 gives me 1.25. So 1.25% per month. Okay, but we need to turn that into our value of R, and our value of R is given by 1 plus little r on 100. Well, this value here now is our little r. So to work out our capital R, I do 1 plus 1.25 divided by 100, which gives me 1.0125. Now I can do this in my head. My advice to you guys is use your calculator, unless you can do it in your head. Anyway, so there is my value of R. I now need to write this in terms of a recurrence relation. Now, bearing in mind this is now monthly. Our recurrence relation is monthly. We know that V0 was her initial amount, which, if I remember, was $1,000. So that's 1,000, then you do a comma. V of n plus 1 is equal to our value of R. We've just worked that out, 1.0125 multiplied by V of n, that stays exactly what it is, minus some sort of repayment. Remember, she is making a repayment of $257.85, and lo and behold, that is my recurrence relationship. Thank you very much. Now, obviously, we can use that information to then do some calculations. It just so happens that's what the textbook wants me to do. Is this any different from the stuff you've done before? No. All right, the only thing they're now throwing in is this monthly interest rate that you've got to make sure that you take into account. So Alyssa's loan can be modeled by that recurrence relationship. Yay, we got the right answer. Fist bump. Use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. So we've got V0 we know is 1,000. Then we have V1, V2, V3, and V4 because she's making 4 payments off of her loan. Bringing up my calculator and deleting all of the rubbish that we don't need there. If you remember, I'm going to do 1,000 and hit enter. That's going to put that initial value in, and then I'm going to do 1.0125 multiplied by my previous answer. There we go. Oh, syntax error. Try that one again then. Answer. And then we are going to take away from that 257.85. Hit enter once, gives me 754.65. Now what you've got to realize is happening here is our $1,000 is having interest added. All right, so when we times it by 1.0125, what that is really doing is adding the interest before we subtract the 257.85, right? So we always, with banks, add on the interest first and then subtract our payment. So there's V1, let's do it again for V2, $506.23, $254.71, and then, well, basically 4 cents. Oh no, yes, 4 cents. Now you'll notice by doing it on my calculator, I'm leaving all of those decimal points in. Makes life easier because if you round the first value, you're going to get the second value slightly wrong. You keep rounding, you're going to end up with rounding errors. Not a good idea at all. There we go. So what is the balance of the loan after she has made 2 payments? Well, give your answer to the nearest cent. After she made 2 payments, $506.23. I'm just reading off my calculator, really. Is the loan fully paid out after 4 payments have been made? Nope. If not, how much will the last payment have to be to ensure that it is paid? Well, she in her last payment, or in all of her payments, has paid $257.85, but she owed those 4 cents. So it would make sense to add on those 4 cents to make her final payment $257.89. Yay! Going to reduce my calculator. And that's it, ladies and gentlemen. So that's how we can use the formula in our calculator and recurrence relationships to model reducing balance loans. Now, one of the big ones, and trust me, if this isn't in a sack, I'll be very, very surprised. Amortisation tables. Sounds complicated, doesn't it? Well, it's more like reading your statement from the bank. All right? I don't know if you've got bank accounts. Hopefully you have. Hopefully you've got some money in there from the jobs you're doing, blah, 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 blah. But when you read your statement, basically it's got credits, it's got debits, it's got your final amount, there's interest payments. That's all an amortization table is, okay? It's about showing you where you were at the start of the year, what money's gone in, what money's coming out, and what you've got left at the end of the year. Marvelous. So we're going to look at an example. So I've taken out a loan of $1,000 with my annual interest rate of 15%, and I want to make payments of $257.85 per month. Sounds very familiar. I wonder where I got this example from. Oh yes, the textbook. How many months will it be before I clear the loan? Now, basically, long story short, let's just see how the table's set up. We have a payment number, and you'll notice that payment 0 is always my opening balance. Then we have a payment. So when we're doing amortization tables, generally we're going to pay something off of the loan. We might pay money into an account. We might pay money off to clear a loan. Works in exactly the same way. We have interest being charged on the loan. We have this principal reduction. Now this is the column that tends to confuse just about everybody in an exam, but don't worry about it. And then we have the balance of the loan, and I'll explain where each of these comes. So, when will I have paid off my loan? Well, basically, I've made the table longer than I needed to. Anytime the values have gone into negatives, I don't need to worry about them because that's basically not going to happen. So here we go. Here is that 4 cents that I still sort of owe at the end of my last payment, which is why I would make my last payment there $257.89. Not really as simple as that in real life, but it's not too far wrong. Where will my final payment be done there? Why is the interest column having different and falling amounts? So if we look at this interest column here, firstly, my interest was $12.50, then $9.43, $6.33, $3.18, and then finally nothing in that situation there. Now, why would that be? Well, as my balance of my loan falls, as I pay more and more of it off, I should be paying less and less interest. So that's why my interest column goes down. And why is the principal reduction growing? Well, because we initially are paying off $257.85, but they are adding on interest. If you remember, when I spoke a moment ago, we add the interest on first, then we take away any payments. So interest in this situation is really a negative value. So if I do $257.85 and I take away $12.50, then I'm going to get $245.35. This is what I'm paying in. This is what the bank is effectively saying, no, you're not, because that's interest, you're going to pay that to me. And so this is what my principal reduction is here, $245.35. How do we get this value here? Well, we've had $1,000 for my loan, and I'm going to take away $245.35, which will give me $754.65. All right, so that's that example. Let's just look at the next line, just to try and sort of make it clear. So we'll look at the next line here. My payment in isn't changing. I'm still paying a fixed amount of $257.85. My interest has gone down. Why? Well, now I'm only paying interest on $754.65. So smaller amount left in of my loan, small amount of interest. This value here should start to grow. Why? Because when I do $257.85 and I take away the $9.43, I will get $248.42. So that value there is what I'm going to subtract from the balance of my loan to give me $506.23. And you just keep going and going and going in exactly the same way. Ladies and gentlemen, I cannot say how important it is to learn these amortization tables. One thing before we move on is a column called cost of the loan, all right, or how much this loan is going to cost. One of the important things you will need to understand is what the term cost of the loan means. Now, when you borrow money, you are going to pay back way, way more than you borrowed. It's the whole point of borrowing money. You're paying interest. The money you pay on top of the amount you borrowed is the interest. It is also the total cost of the loan. So for example, if I borrow $1,000 and I pay back $1,463.32, this here, this $463.32 is my interest, but it is also the cost of my loan. This figure here, $463.32, is how much the bank has charged me for loaning me that $1,000. Thank you very much. Okay, so how do I find my interest? Again, I either do 1463.32 minus 1,000, which gives me the 463.32. I know I said either, that's it. That's literally how you do it. Okay, so if we look back at our previous example, what we noticed is we kept making these payments, and you'll notice that last one now has been adjusted to 89 cents to clear the loan. Our total payment, all of the payments we made, $1,031.44. How did we get that? By adding all the payments together. But what do I notice? 1031.44. How much did I borrow? $1,000. Leaves me 31.44, which just so happens, ladies and gentlemen, to be how much interest I was charged as well. And how do we get that value? Added all these columns up. So the great thing about amortization tables is they're not particularly challenging if you understand how all of the columns are created. The cost of the loan one is the one that throws a lot of people. Here we go. The following example has been extracted with permission from the Cambridge Further Maths Units 3 and 4 textbook. A business borrows $10,000 at a rate of 8% per annum. Notice how I always highlight the things that are important to me. I want to be drawn to that in an exam if it's helpful. The loan is to be repaid by making 4 quarterly payments of $2,626.20. The amortization table for the loan is shown below. Now, quarterly payments. First things first, whenever I see 8% per annum and quarterly payments, I know my percentage, my interest rate is going to have to change. The amortization table is shown below. What do you notice? 1, 2, 3, 4 figures are missing. Guess what I'm going to have to fill in? Those 4 figures. Oh, this is a SAC question. I can feel it in my water. So let me see. Determine the quarterly interest rate. So there are questions that we're going to work through here. But the first one says determine the quarterly interest rate. Well, my 8% per annum. There are 4 quarters. So I'm going to do 8 divided by 4, which gives me 2%. So there's my interest rate per quarter. Thank you very much. What does it say now? The interest paid when payment 1 is made using our quarterly interest rate. Okay, so if you remember, how do we do this? We need to do an interest rate of 2% on the balance of this loan. So basically, the easiest way to do it is 2% of $10,000. Okay, so 2% of $10,000 gives me, well, 2% is 2 on 100 of is times 10,000. So firing up my CAS calculator, let's do 2 divided by 100, and we're going to times that by 10. 1, 2, 3 gives me the staggering value of $200. All right, so that first interest payment there is going to be $200. So there is 200. Now, the question is, could I have checked that with any other figure on this table? Well, actually, yes, we could. Look at this, principal reduction, 2426.20. Our payment made was $2,626.20. Our principal reduction was $2,400. So remember, they've deducted interest from this figure here. They've said, well, that's how much you're paying, but I'm knocking off some for interest, and that will be your principal reduction. So I didn't even need to do any of this. I could have actually just subtracted those 2 values. Oh, that's annoying again. Further maths, love it. All right, so the principal repaid from payment 2. So it's just working us down. Realistically now it wants us to do this box, but we know how to do this box. We know that this box is going to be this value here minus that value there. Okay, so 2626.20 minus 151.48. It gives me the staggering value of 2474.72. So I'm just going to do the working out here for those people who want to do the notes. So that was 2626.20 minus 151.48, which gives me 2474.72. And again, remember, this is how much we're trying to take off the loan, and this is how much interest they've charged me. And this is what my loan will be reduced by. Let me guess what the next one is. The balance of the loan after the payment 3 has been made. So just getting rid of that working out here. We now know that this box here is this balance of the loan at the end of the previous payment subtracted our principal reduction. So we're going to do 5099.08, and we're going to subtract from that, if you will, 2524.22. And that is going to give me, let's just delete that box, 2574.86. Oh, thank you very much. And then let's just see, let's just get rid of this box here and this box here. So I'll scroll up and do the notes. The balance of the loan after payment 3 has been made. 5099.08 minus 2524.22 gave me 2574.86. The total cost of repaying the loan. This is the one I told you about. The total cost of repaying the loan. Do you remember how you can do this? You can either add up all the interest, or we can add up all of the payments. Now what I'm going to do is I'm going to do both to prove. Let's rub this out. So the first thing is, let's add up all the payments. So 2626.2. I'm going to multiply that by 3, and then I'm going to add on to that 2626.36. So all I've done is added that first column of payments made. So 10504.96. How much did we actually borrow? Well, we borrowed 10,000. subtract those is going to give me 504.96. So that's actually the cost of my loan. But is there another way of doing this? I should add all the interest. So let's just do 200 plus 151.48 plus 101.98, not minus, plus 51.50 gives us OMG $504.96. So there are two ways of doing this. So I'm going to write down there that it is equal to $504.96. I should keep putting the dollar signs in there, but anyway, verify the total amount of interest paid is equal to the total cost of the loan minus the principal. I've just done that. I don't need to do it again. And ladies and gentlemen, that's pretty much it for this lesson. But before I scroll to the top and do my goodbye, please, please, please learn how an amortization table works. It is, once you've got the idea, phenomenal, and you'll be able to do these things like a gun. And so that is the end of analysing a reducing balance loan with recurrence relations lesson. We start to move on in the next lesson to the CAS calculator financial solver, which is awesome, but a little bit tricky. All those videos are already loaded. I look forward to seeing you in another video. If you haven't already done so, can you subscribe? Again, just lets me know you're watching and greatly appreciated. Have a good day. I look forward to seeing you in our next video. Take care. Bye-bye.